Look, I know you're tired, but that's okay, because this is the only video on limits you'll ever need to watch for grade 12 calculus. Trust me. We're going to go over 3 example problems and solve them step by step. Without further ado, let's get started. So this is case 1 of 3. You're mainly going to see 3 cases, and this is probably the most common one. A limit with polynomials in the numerator and polynomials in the denominator. As soon as you see polynomials in any limit, and you're in grade 12 and you're writing a calculus exam, the first thing that should come to your brain is factor. To solve this limit, we're going to factor the numerator and the denominator. So we have x squared minus 6x plus 9. What are 2 numbers that add to negative 6 but multiply to positive 9? So if we're multiplying to a positive but adding to a negative, we're going to have 2 negative numbers, right? So x minus 3 and x minus 3. Negative 3 plus a negative 3, that's negative 6. Negative 3 times negative 3, that's a negative 9. So that's our numerator fully factored. X minus 3 and x minus 3. Okay, so now let's factor the denominator and move along with the problem. So this is a sum and difference of cubes problem. X squared minus 9, we're going to get an x minus 3, and then the positive case, x plus 3. Just like that. Super simple. And then we're going to add that to our denominator in our problem here, x minus 3, then x plus 3. Okay, now it's time to move on, so I'm going to erase all this factoring work we did. Okay, so I've pulled down the factored form. Can we compute the limit yet? No, because the next step after factoring is always to cancel. Step 1 is to ID the limit, and we identified that limit as a polynomial limit. Whatever you want to call it, a limit with polynomials. What is the method when we have polynomials? It's to factor. So the second step is to apply the method. The third step is always to cancel. You cannot compute before canceling in these problems. After we cancel, then, and only then, we can compute the limit. Okay, so let's cancel. So we have a negative 3 in the denominator and a 2 negative 3's there in the numerator. So we can cancel 1 out with 1 in the numerator. And that leaves us with x minus 3 in the numerator and x plus 3 in the denominator. Now we can compute this limit. Here we're taking the limit as x approaches 3. All you have to do is replace the x values with 3. So 3 minus 3 divided by 3 plus 3. This gives us 0 in the numerator and 6 in the denominator. So that's our answer, 0. So what you would say is as the limit of x squared minus 6x plus 9 divided by x squared minus 9 approaches 3, it equals to 0. And that's how you would say that. So remember the steps and you can solve any of these problems. Okay, so on to the next example. This one looks harder, but I'm telling you it's way, way easier than the last one. You don't have to factor. This takes 2 seconds and it's just a bunch of algebra. This type of limit is what I like to call the conjugate limit, or the multiply by the conjugate limit. And the conjugate is best explained through this definition, I think. So if we have the square root of f of x minus a, the conjugate of that would be the square root of f of x, nothing changes, plus a. And the reverse is also true. So let's apply this logic to the problem. To defeat these limits, all you have to do is multiply the numerator and the denominator by the conjugate of the term with the square root in it. So the term with the square root in it is our numerator, and always, 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 what's under that square root stays the exact same. The only thing that changes is the sign of the constant term. So minus 3, the conjugate would be plus 3. And we do the same thing to the denominator. 9 minus x plus 3. Now it's just algebra. Okay, so let's do the numerator first. We have this 9 minus x term multiplied by this 9 minus x term. That negates the square root and just leaves us with 9 minus x. And then we have negative 3 multiplied by positive 3. And that's negative 9. And then the denominator is just x times that whole expression. So x times 9 minus x plus 3. Don't forget your brackets. Okay, so first things first, after we do our method, and our method was the conjugate method, right? What do? We cancel. Okay, so let's cancel. 9 minus 9, that's 0. So these 9s are going to cancel out. And we're left with negative x in the numerator. In the denominator, we have x times this whole expression. Do you notice something? Should we multiply that x into the bracket? No, because we can actually cancel it with the numerator. So x canceled with negative x. That leaves us with negative 1 in the numerator, and then that whole expression on the bottom. So 9 minus x plus 3. So now we have finished canceling and we can compute the limit. So the limit of negative 1 divided by the square root of 9 minus x plus 3 as x approaches 0 computes as negative 1 divided by the square root of 9 minus 0. So square root of 9 plus 3. This is equal to negative 1. Square root of 9 is 3. So we have 3 plus 3 in the numerator, or the denominator, which is 6. So the limit as x approaches 0 is just negative 1 over 6. Pretty easy, guys, right? So we apply the method. In this case, the method is the conjugate method. We multiply everything in, numerator and denominator. We cancel. We cancel again. And then we just compute the limit. Very easy. So the next one is probably the hardest example. But once you do it a few times, you'll be fine. Okay, I know what you're thinking already. Oh my God, there's 2 expressions. So annoying. And I agree. But you know what's not annoying? Finding a common denominator. I think it's super easy. And just doing this a few times will save you tons of marks on your test. Trust me, this is the only other case you'll see. You'll have factoring, you have the conjugate method, and you'll need to find common denominator. So this gets a little bit tricky because sometimes in these problems, you need to actually factor first before you find a common denominator. And in this case, you do. So our first expression, 1 over x plus 2, is fully factored. It's fine. We just leave it alone. But our second expression, 5 over x squared minus x minus 6, is not fully factored. So we need to find 2 numbers that add to negative 1 and multiply to negative 6. So negative 3 plus 2 is negative 1, and negative 3 times 2, or 2 times negative 3, is 6. So we have x plus 2 and x minus 3. Fairly easy. And now we can find a common denominator. So what are we missing between these 2 expressions? So x plus 2 and x minus 3 has it all. But x plus 2 is missing something. It's missing that x minus 3. So what do we do? Well, now we have to fill the need. We have to multiply that expression by x minus 3. But not just the denominator, the numerator too. Whatever we do to the bottom, we must do to the top. So first, let's write the common denominator. So x plus 2 times x minus 3. Our first expression there is missing x minus 3, so let's fill the need. Multiply x minus 3 to that 1 in the numerator. So 1 times x minus 3 is just x minus 3. And then our other expression already has this common denominator that we selected. So it's not missing anything, so we just leave it alone. So add the 5. Okay, so we've pretty much done everything we need to do in the first 2 steps. Identified the problem, applied the method. Now we can cancel. So let's cancel. What can we cancel in the numerator? We can just simplify this. So 5 plus negative 3 is just positive 2. So let's just change that to positive 2. So we have x plus 2 and x plus 2, and we're going to cancel those out. And then we're left with the limit as x approaches negative 2 of this, of 1 in the numerator, and then x minus 3 in the denominator. Let's clean this up. So the numerator doesn't change, there's nothing there. There's an x in the denominator, so let's put a negative 2 there, minus 3, and we get 1. Negative 2 minus 3 is minus 5. So the limit of 1 over x plus 2 plus 5 over x squared minus x minus 6 as it approaches negative 2 computes to 1 over negative 5. So we identified the problem up here. We identified this as a common denominator problem. And what do we know about these problems? Sometimes you need to factor first. And in this case, we did. So we applied the method. 3, we canceled. And 4, we computed the limit. That's it. Common denominator problems, polynomial problems, and conjugate problems are all you're going to see on your grade 12 calculus exam. That's it. Now, I hope you liked this video. I kept this one pretty short. Good luck on your exam, guys.